Okay, so I'm going to go over your stoichiometry practice test question. I'm going to start with the first one where it says, write the balanced equation for when calcium chloride and silver nitrate react. Identify the solubility of each compound. So for this particular one, calcium chloride would look like this. You have CaCl, because Ca has a +2 and Cl is a -1. You need a 2 down here. If you looked up the solubility of it, it is Aq plus silver nitrate, AgNO3. It's a +1 and a -1, so it's good. Nitrates are always soluble, so it looks like that. Now this is an ionic compound plus an ionic compound, which is going to make it a double replacement. So the Ca right here is going to combine with NO3, and you're going to get CaNO3 because I used my charges. If you look up the solubility, this is Aq. And then the insides are going to go together, Ag with Cl. Notice I don't carry that 2 over because it's not part of the polyatomic. So that one would be Ag, which has a +1, and Cl that has a -1. And that is actually your precipitate S. Okay, now we're going to balance it in green. I'm going to put a 2 right here and a 2 right here, and I'm going to call it a day. Now, this first question. Using the correct balanced equation, determine the maximum amount of the precipitate that will be formed, which means I'm looking for this. This is my unknown. From 34 grams of calcium chloride and 56.1 grams of silver nitrate. Okay, I just zoomed in a little bit. So I'm going to take my first given and I'm going to solve it. I'm not going to show out all my work because there's not a whole lot of space, but my given is 34.2 grams of calcium chloride. And my unknown is my precipitate, which is AgCl. Yeah. Okay, so your first step, if you're given grams, is to convert this to moles using the molar mass of CaCl2. So you look at the periodic table, take the mass of Ca and add it to the mass of 2 Cls. And that is 100.98 grams of CaCl2 and 1 mole of CaCl2. This step is always 1 mole. Okay, now we're going to use our relationship from our unknown to our known. Our known is CaCl2, and there's not a coefficient in front of it, so we assume it is 1. Our unknown is AgCl2, so the ratio is 1 to 2. Now your known would go on bottom so that it can cancel out. Please remember that all that's canceling out here is your mole of Cl2, not your number. It just is a coincidence that they're both 1s. Now it's 2 moles of AgCl that goes on top. And I'm going to go ahead and go all the way, that's a mole by the way, I'm going to go ahead and go all the way to grams. So I'm going to put 1 mole of AgCl2 on bottom, and I'm going to put the molar mass of that on top. 143.32 grams. Now I'm going to multiply all of the top numbers, and I'm going to divide by the bottom numbers. And I get 88.33 sig figs. I should only have 2. And this is grams of AgCl. Okay, now that I did that for one given, and now you have to repeat for the second given. The second given, I'm going to work here for number 2, but it's really the work that goes into number 1, is 56.1 grams of silver nitrate. And you go through this entire process again. So I am actually going to just work it out really quick and then show you what that looks like. Okay, so I worked this out, and I took my grams of AgNO3. I used the molar mass of AgNO3 with 1 mole of AgNO3. Then I used my ratio from my balanced equation from my known to my unknown, which just happened to be 2 to 2. The AgNO3 went on bottom so that it canceled. Now I have AgCl on top, and I'm going to do the molar mass of that, which is the same as it was before. And then you're going to get an answer. So ignore what's over here in blue because that went from up here. When you multiply the top and you divide by the bottom, you get 47.3 grams of AgCl. Now, question number 1 is asking for what is the maximum amount of the precipitate. So we took our 2 givens and we've solved it 2 times. But the actual maximum amount, even though it says the word max, the maximum amount is truly your smaller answer of the two, which means your answer, that just looked like I crossed that out, so let me back that up. Your answer is the smaller answer, which is what I am circling in green, 47.3 grams. 88 is bigger. I do not care about that number. I don't want to see that number as an answer ever. No matter how it words, even if it says the maximum amount of precipitate, it means the smaller answer because you run out of your limiting reactant, which is AgNO3, because this made your theoretical yields. So some vocab that you have to remember is that this right here is called your theoretical yield, and whatever makes your theoretical yield is your limiting reactant. So AgNO3 is your limiting reactant. Okay, now question number 3. How many grams of the excess reactant is used? This is where you take your limiting reactant, and we're going to see how much excess is needed to react with that. You're going to solve it the same way, but instead of solving for AgCl, your unknown is now your excess, which is CaCl2. So we're going to take the 56.1 grams of AgNO3. Okay, I'm actually going to erase a little bit, so make sure you have us all down or go back in the video. Okay, so 56.1 grams of AgNO3. We're going to use the molar mass of AgNO3. Oops, I just wrote that down wrong. But now you're going to use your ratio from AgNO3 to your excess reactant. So this time I'm going to highlight that in red. So AgNO3 is right here, and we're going to go to our excess reactant, which is over here. So it's a 3 to 1. I'm sorry, a 2 to 1. That 2 would go on bottom so that the AgNO3 cancels out. And 1 mole of CaCl2 goes on top. And we continue this another step. I'm going to stay in red so it doesn't run over with that 47.3. So you're going to use the molar mass of CaCl2. The molar mass of that was 110.98 grams. So now you're going to multiply the top, divide by the bottom, and you get that the answer is 18.32 grams. Now this is how much is used. So this is your answer for number 3 up here. Okay, I'm just running over. So when it wants to know how much excess is left over, well, the 18.32 is how much was used, but you were actually given 34.2 from the original problem, so 34.2 grams minus 18.32 grams. Make sure they're both in the same unit, otherwise you have to do another conversion. And you get that your final answer for number 4 would be 15.88. So these two subtracted is 15.88 grams. So that would be your answer to number 4. Now number 5, a student in the lab conducted this experiment and determined that 43.2 grams of the precipitate was actually formed. What is the percent yield? So the percent yield equation is one that's on the back of your periodic table, so you don't have to have it memorized, but it's percent yield equals actual over theoretical times 100. Your actual is given to you right here. This is what happened in the lab, so it's 43.2 grams. You're going to divide by your theoretical, which remember was that 47.3 grams, and you're going to multiply that by 100. Make sure that these are in the same unit at all times, and you get that your percent yield was 91.3%. Okay, and put the percent sign on the end. All right, now your complete and net ionic equations. This part is just a review from before. It has nothing to do with stoichiometry. It has to do with taking this equation from the top and breaking it apart if they're AQs. So CaCl2 is AQ, according to the very top right here. So we're going to break it apart, and we're going to write Ca with a +2 charge. The +2 shows that it really is in a compound, but it's AQ, so it's dissolved and it's broken apart. plus 2 Cl's. Notice that that subscript becomes a coefficient. It has a -1 charge, and it is also AQ. Plus your AgNO3 way up here. There's 2 Ags. They're plus 1, and it was AQ. Plus 2 NO3s. Each one is a -1, and it's also AQ. Arrow. Go ahead and put your arrow. Okay, I'm going to continue this down here, and then I'll show you net ionic in a minute. CaNO3 up here, it is AQ. So Ca plus 2 AQ plus 2 NO3s AQ plus AgCl2, or 2AgCl was the S. It was your precipitate, which means it stays together. You leave all S's, G's, or L's together. That is your complete ionic right there. So again, if it's AQ, you break it apart and include the charge. If it's an S, G, or L, you leave it together. You need to make sure that everything matches left to right. What I mean by that is, if you have 1 Ca, you need 1 Ca. 2 Cl's, you need 2 Cl's. 2 Ags, you need 2 Ags. 2 NO3s, you need 2 NO3s. And then you can look from left to right to determine what is not changing. See, Ca plus 2 is AQ, and it stays AQ. So when you write your net ionic, these get canceled out. 2 Cl's as AQ became 2 Cl's that are S with an Ag, so you're going to leave that alone. Again, same with the 2 Ags. Now 2 NO3s are AQ, and they're still AQ here. So these get canceled out because it's the same. Whatever's the same, you cancel out, and you leave behind everything else. That is your net. So your net ionic is whatever you didn't cross out. So I didn't cross off my 2Cl -1 that has an AQ. I did not cross off my 2Ag plus 1 that's AQ. And I did not cross off my 2AgCl that became a precipitate. So that's your net ionic.